All right, this is the first practice problem, and I'm going to pause it again. So we don't need the Ka at all. In fact, that's just a made-up number completely for this one. Has nothing to do with the problem because I don't have a weak acid or a weak base, right? So this is just a straight titration or neutralization, whatever you want to call it. Oh, sorry, I hit next, sorry. To wake this thing up, you hit a button, and sometimes I hit the next button. Okay, so we just have to find out which one is in excess, right? So which one is in excess? What's that? The OH minus. Do we all agree with that? Okay, so I'm going to take 14 and I'm going to subtract anything I do right here, correct? Because all the math I'm going to do right now is going to find the POH, but the problem is also always asking for the pH. So pH is equal to 14 minus POH. Okay, so this math, what was the concentration of excess hydroxide? What? 0.02. Divide by 3. Are we okay with that? Let me just move this over. Okay, and then I'm going to take the negative log of whatever this ended up to be. It's like 0.006666 or something like that, right? And I didn't need that big. I don't need to do any other math, right? So I just end up with 11.8. Who agrees? Raise your hands. Okay, not bad. So if tomorrow, and there'll be one, if you see just OH and an H, find the excess and then do the math. Just make sure if it's a base, you have to subtract it from 14. Okay, number 2, give this a shot. So in this one, we have a strong acid, and then we have a salt with a common ion, correct? So I have 0.1 mole of H plus, correct? Then I have how much? 0.1 mole F minus. They will combine to make 1 mole of HF. Is there any excess F minus? No. So is this a buffered system? No, not a buffer, correct? So all I have here is, sorry, 0.1 is that's why you're looking at me funny, my bad. All we have here is an amount of weak acid, right? Okay. Now, whenever we do this, this is in moles, so I better divide it by 2, correct? Right? Because I need the concentration. So my initial concentration of HF will be 0.05 molar. And we know that Ka for a weak acid, I'll just put it right here, is equal to x squared over initial. And x will eventually be my concentration of hydronium, which I can then take the negative log of. So I have Ka 6.8 times 10 to the negative 4 is equal to x squared over 0.05. Then I'm going to multiply both by 0.05 and take the square root. So before someone just does it, what's x equal to? Anyone have it on their calculator? 0.0058, right? So then we take the negative log. Okay. Of that, and that will give me my pH. You have it, Maddie? 2.23. Okay. So the previous one we did had strong acid, strong base. So we just found excess and went from there. This one is one of those where you're gonna have to figure out if there's a buffer and then do math based on if there is or not. So strong acid plus a common ion. You got to do the chemistry first and then find if you have excess conjugate base left. If it's equimolar, you just end up doing just the Ka for your weak acid and solving for X. If there was excess fluoride ion, we would use what equation? Henderson-Hasselbalch. Okay. If there was not, let's say there was less. So if you only put in 0.1 liter, then this problem you would have had excess H plus, and you just take the negative log of that concentration. Okay. Number 3, there's the answers. Oh no. What is the pH of a solution mixing this and that? It's the same stuff, this time just different numbers. Give it a shot. So we look here, same exact problem, just different values, right? So this time we have 0.18 H plus, correct? And we have 0.1 F minus, correct? So how much HF do I make? So I make 0.1 HF. And then what's left over? 0.08 what? H plus. So is this a buffer? No, it's tricky. It has an amount and some excess, but it has to be excess conjugate for it to actually be a buffer. So there's only one number I care about right now, the H plus. So like all this information was important, but all I care about is the H plus. So do I need to do 14 minus? No. All right, so I do need to do one more thing to this H plus, and what is it? Divide it by the total volume. Okay, so that's the molarity. I take the negative log of 0.04 and I end up with something real strong. Okay, so if there's excess H plus, it's not a buffer. It's just an acid. Hold on, I gotta get ready in case the next one has the answers too. Ooh, that was close. You got them memorized? Hey, I have a feeling this one will be what? This one will probably be a buffer because we've done the only other two options. Good call. All right, here we go. Thank you. 0.08 of H plus, right? I mean, I try to make it easy, but they're just ones. All right, 1 times 0.1 is 0.1 F minus. All right, there you go. A lot of you need tomorrow's test to go well. There's only one more test after tomorrow. Uno más. You got to do good on 2 of them. Ooh, I better go fix it. There's definitely. How many of you are at 100% right now? Weird. Okay. Here we go. So how much acid do I make? Is there excess F minus? What is its concentration? Are we all right with that? So finally, is this a buffer? Yes. So pH is equal to the negative log of the Ka plus the log of B. which is which one of these two? F minus over A. Can someone tell me why I didn't divide these to get their molarities?
Because then it would cancel out again.
They cancel out. Okay. So what do we end up with?
2.5.
Okay. We all right with that? Good. I feel good about it. Oh, there they are again. Wow. Hey, number 5, look. Number 5, this is the same stem, same numbers and everything. Okay. So it's the same thing it was before, but now we're adding 100 milliliters of 0.1 NaOH. Yeah, the same numbers as before. Well, hopefully by this time in your career, you know how to go from grams to moles. We dang well should be able to. All right. So there is 0.00741 grams. What's the molar mass of this? Like 62? I hate being genius. Oh my. And this equals what number then? 115. All right, we okay with that so far? That's the moles. But we still need one more thing. What's that? Okay, so this is 100 milliliters, so I got to divide this by 0.1 liter, correct? Who's with me so far? Okay, so that's how I find the molarity of what I have here. So it is 0.001195, right? Okay. Now, there's 2 ways to do this process. I personally would already have memorized that a KSP for a 1 to 2 things was 4x cubed. That's what I would do. So I would say the KSP is equal to this times 4 cubed. Or I say KSP is equal to that number times 2 times that number squared. This is like the actual real KSP expression written out with the things inside of it. Why did I put a 2 right here? Good, because for every 1 MgF2 that breaks apart, 2 F minuses are made, right? Okay, or I had simplified it to 4x cubed, because when you square the 2, it makes it 4 times that. And then you square that value and multiply it by that one again. That's a cube. All right. Apparently my finger bends different. Oh, it looks so miserable right now out there. Oh well. Okay. Try this one real quick. Oh, this should, I'm not gonna pause the video. This should go fast. It's a 1-to-1. All right, we ready? So just the basic expression, KSP for this would be equal to Ca plus 2 times SO4 minus 2, and it should have been brackets, cover concentration. Forgive me. All right. There was no subscripts, so there's no coefficients, there's no squaring, there's no nothing. So I don't know this value, so I'm going to say KSP is equal to X, but I do know that this is also the same number, right? Or X squared. So all I have to do is take the square root of this, and it will give me my answer. And that would have been someone 0.003
Yes.
11.
0, 1.
I don't care. Something like that. KSPs are a piece of cake, I hope, right? Okay, I'm going to look. You're going to crowdsource this between each other. Yep, the answers. So here's the problem. And I'm going to end the video here in a second. Get it processing. Yeah, absolutely. Anyone take a picture. And then in your AP group chat, you figure out the answers over the next little while. Okay, you all right with that? If you go a year or two ago and find the test review, this might be there. You would honestly look up AP 2021, chapter 17, and see how many videos there are. I'll bet you there's a video on it already. Okay, I'm going to end the meeting so we can get things processed in time. I paused it a